Okay, so moving along with our work on derivatives, the next thing that we're going to talk about is how to take a derivative of a trigonometric function. We're going to start off with sine x and cosine x and work from there. So, the derivative of sine x, as you can see on the screen, is cosine of x. And the derivative of cosine of x turns out to be not sine of x, but actually negative sine of x. You can also write this with the function notation as well. So if your function is sine of x, remember the notation for the derivative, if you've got a function, is the prime. So f and f prime is the derivative. Derivative of sine of x is cosine of x. And if your original function happens to be cosine of x, then the derivative turns out to be negative sine of x. So definitely go ahead and write that down, and you do need to eventually memorize those derivatives. And let's look at some examples. Well, suppose we're asked to find the derivative of tangent of x. Well, remember that tangent of x is sine over cosine. So, we will need the quotient rule for that. So, let's review the quotient and product rules very quickly. So recall that if you're taking the derivative of a product, well, what you do, say for example, you're taking the derivative of a first function times some second function, then what you do is you take the derivative of one of them, leave the other one alone, then there's a plus in the middle of the formula, and then flip it. The first is left alone, and take the derivative of the other, the second one. So it's derivative of the first times second plus first times derivative of the second. Recall that this is when you have a function times another function and you're trying to take its derivative. We also have, and again this is called the product rule, I can write that down for you. And then we also have the quotient rule, which is when you have a dx of a quotient. There's different formulas for this, well, different ways to write the formula. It's the same formula, of course. But my favorite is to call it high over low. And then the derivative is actually low d high minus high d low over low squared. So it gives you a little way to remember it. Low d high minus high d low over low squared. This one is the quotient rule. All right, so let's move on to our example involving tangent. So if we're asked to find the derivative of the tangent function, well, we remember at the beginning of the lesson we only talked about derivative of sine and cosine. So our technique here is to write this in terms of sine and cosine. So we're looking for the derivative of tangent. So we're going to write that as us needing to take the derivative of sine over cosine. right? So what we're really looking for is the derivative of the function sine over cosine. Now, obviously, we're going to need a quotient rule for that. So if your original function is a quotient, then we'll need the quotient rule to find its derivative. So this is our original function, so the derivative is going to be low d high minus high d low all over low squared. And the way you interpret this is sine is your high or top function, and cosine is your low or bottom function. So the formula tells us first off to leave the bottom function alone, so don't differentiate it, just leave it as is. That's cosine of x, right? Then that prime tells us we've got to take the derivative of h, and that's the high function. Now, don't forget, derivative of sine of x is cosine of x, which was stated earlier. So the derivative of h is actually cosine of x, so that's what goes there, minus the high function left alone, which is just sine of x left alone. And then for the L prime, that's d low, or the derivative of the low function. Recall that the derivative of derivative of cosine, which is the low function, is negative sine. So d low, or low prime, is where we multiply a negative sine of x. And all of this is actually over low squared, so cosine of x squared. So again, low d high minus high d low over low squared. Well, continuing on. If you've got cosine squared, this is just a notational thing, but you can write the square there instead to save yourself from writing parentheses. Again, it means the exact same thing. So here we've got cosine times cosine, right? So that's cosine squared, and I'm going to write it using that shorthand where the square goes there. Now we got a negative times a negative here, which becomes positive, and sine x times sine x is going to be sine squared of x. So this becomes plus sine squared of x. Well, at this point, technically we've taken the derivative. That's technically done now. But we can simplify this a bit. Now remember that we have the Pythagorean identity. It's based on the Pythagorean theorem. That sine squared of x plus cosine squared of x equals 1. So that numerator right there is actually just the number 1. So this is 1 over cosine squared of x. Lastly, remember you've got the reciprocal identities. There's sine, cosine, tangent. Now remember that 1 over sine is the cosecant, 1 over cosine is secant, and 1 over tangent is cotangent. So since this is 1 over cosine, it's the same thing as secant, and since it's squared, it's going to be secant squared. So this can be rewritten without a fraction as secant squared of x. So what we found here is that the derivative of tangent is secant squared of x. Let's try another one. This time we're going to try to find the derivative of secant of x. Again, recall you've got sine x, cosine x, and tangent. And remember that 1 over sine, the reciprocal of that, is defined to be cosecant. 1 over cosine is defined to be secant. And cotangent is 1 over tangent. Nope. Didn't mean to erase that. Just that. Yes, so 1 over tangent of x is called the cotangent of x. All right, so anyway, we're looking for the derivative of secant of x. Well, what does this mean? Well, your original function is secant which, since we only know the derivative of cosine and sine and tangent at this point, we want to write secant as something that we know. Well, 1 over cosine will work because, again, we know the derivative of cosine, so we should be able to work with that. All right, and then notice how, since we do have a quotient here, we will be doing the quotient rule on this. So that's our original function. When we do its derivative, we're going to be doing low d high minus high d low all over low squared. And a couple of things to remember. The derivative off to the side, derivative of cosine of x is negative sine. And the derivative of a constant is just 0, so the derivative of the number 1 is just 0. So that'll be helpful to us as we're working here. So again, following the formula for the quotient rule, the low function left alone is just cosine of x. Derivative of the high function, that's derivative of 1, which is 0. Formula calls for subtraction after that. High function left alone is the number 1. And derivative of the bottom function, the low function, which is cosine of x, is times a negative sine of x. And this is all over the low squared. Now remember, cosine squared, all squared, is the same thing as writing cosine squared of x, just like that. Now the first two things multiplied together, 0 times anything is just 0, right? And then when you're considering these two, a negative times a negative is a positive. So 0 plus sine x is what's on top, which is just sine x. And this is over cosine squared of x. Now at this point, you have technically found the derivative. If you want to simplify it a little bit more, remember that tangent of x is sine over cosine. So if you think about getting rid of one of those extra cosines, just factor it out. 1 over cosine of x times sine x over cosine of x. Then the second part becomes tangent, right? That's just tangent. And remember that 1 over cosine, that's secant. So this can be written as secant of x times tangent of x. So the derivative of secant of x is secant x tangent x. All right. You can do these for cosecant and cotangent as well. And if you did so, you would end up with derivatives that would match up with this chart. So these are the derivatives of the 6 common trigonometric functions. Notice how we did calculate the derivative of tangent and the derivative of secant from the original sine and cosine derivatives. Similarly, you can do cosecant and cotangent as well. So be sure to write these down. I'll give you a minute to do that. Okay, so we're going to go ahead and go on to more examples. If you're still writing, you can pause the video and copy this down. Otherwise, moving on to the next slide. Let's suppose that we are given this particular function and asked to find f prime. Well, remember that f prime is the derivative. So the original function, sine x plus cosine x. Now we're looking for the derivative here. Notice how we do not need a product rule here because it's not times, it's plus. And remember, when you're taking the derivative of the summation, you can just do the pieces separately. So recall that the derivative of sine x is cosine of x, and recall that the derivative of cosine of x is negative sine. So this is plus and negative sine. Well, that's the same thing as minus sine of x. So the derivative of sine x plus cosine x is just cosine x minus sine of x. There's really not much else we can do to simplify this, so we're done. Now here, notice that we've got a slightly different situation. We've got a product. This is e to the negative x times sine of x. which means we're going to have to use the product rule here. If it had been e to the negative x plus sine of x, we wouldn't have had to do that. But before we jump into the product rule, let's recall a couple of the derivatives here. Now remember, if you have the derivative, if you're looking for the derivative of Euler's number e to a constant times x, remember that the derivative is k, that constant, times e to the kx. So if you have derivative of e to the negative x, that's like a negative 1 times x. The derivative will be negative e to the negative x. And remember that the new information here, derivative of sine of x, is cosine of x. Okie dokie. So we're looking for the derivative of e to the negative x times the function sine of x. So the product rule, derivative of the first times the second, plus first left alone times the derivative of the second. So the derivative of the first function, e to the negative x, its derivative is, recall, it's k e to the kx, so this is negative 1 times e to the negative x. Second function left alone is sine of x. Then recall from the original product rule formula, we do have a plus here. First left alone, e to the negative x. And the derivative of the second function, our second function here is sine. So the derivative of sine is negative sine. Derivative of sine is positive cosine. So this last part right here, we've got cosine of x. And so that's it. The answer here is negative e to the negative x times sine of x plus e to the negative x cosine of x. If you wanted to clean this up a little bit, you could factor out an e to the negative x. And write this as cosine x minus sine of x. But that's about the most you can do to simplify. So if you're ready, we'll go on and try the next example. Well, for this example, remember when you square something, it's the same thing as multiplying that quantity by itself. So for example, 3 squared is 3 times 3. So when we write cosine squared of x here, that's the same thing as cosine of x whole quantity squared. And that is also the same thing as cosine of x times itself. So, in order to do the derivative here, we are going to need to do a product rule. We're going to treat the first function like it's cosine of x, and also the second function like it's cosine of x. And just as a gentle reminder, derivative of cosine of x equals negative sine of x. So we got a product rule, f prime s plus f s prime. Well, derivative of the first is negative sine of x. Second left alone, cosine of x. Plus first left alone, cosine of x. Plus derivative of second one, well, that's negative sine of x. So what we've got here is a negative sine of x times cosine of x minus, same thing, I can put these in the same order, sine x times cosine of x. Since they're just multiplying them, the order doesn't matter. And once I do that, then I can see that these are really just two of the same thing. So this is equal to negative 2 times sine x cosine x. And so that's the derivative here. So derivative of cosine squared is negative 2 sine x cosine x. So just trying something a little different here. Let's suppose that we needed to take multiple derivatives. So remember, f prime of x is the first derivative, f double prime is the second derivative, and f triple prime is kind of obviously the third derivative. So the original function is sine of x. Well, recall, derivative of sine of x is what? Well, that's cosine of x, right? And remember that the second derivative is just the derivative of the derivative, right? It's the derivative of the first derivative. Well, what's the derivative of cosine of x? That's negative sine. And for the final part here, we need to do the third derivative. So we got f triple prime, the third derivative. Now what happens here is we've got a negative sign here already, so the negative is just coming down because it's a constant. It's like a negative 1 times sine of x. So the negative 1 is coming down from the previous. And then you've got derivative of sine x. So remember, derivative of sine x is actually cosine of x. So the third derivative is negative times cosine of x. So that's an example of trig functions where you're having to take higher order derivatives, meaning second derivative, third derivative, on from there. Now, if you're ready, we're going to do one last example. Now, looking at this, I'm sure you can tell right away that this is a quotient rule problem. So recall the quotient rule. Looking for the derivative with respect to x of the top function over the bottom function, high over low. So this is low d high minus high d low, all over low squared. So our original function, sine x over 1 plus cosine x, if we're looking for its derivative, it's f prime. Using the quotient rule, we're going to treat 1 plus cosine x like our low function, the one on the bottom. The formula tells us to leave it alone initially. And then the next thing we got to do is multiply by the derivative of the high function. Derivative of sine x is cosine x. Formula calls for minus sine after that. High function left alone, so that's just sine of x. So this part right here, just plain old sine of x. Derivative of the low function, this part, we got to take the derivative of 1 plus cosine of x. Well, since it's plus, we don't have to do a product rule. It's just derivative of each piece separately. Derivative of the constant 1 is just 0. And derivative of cosine of x is a negative sine of x. From there, this is all over low squared. So at this point, we've technically calculated the derivative. Anything we do after this is just simplification. So if you're thinking to simplify this, the cosine does need to distribute. So what we get here is a cosine of x times 1, which is just cosine of x. Then we've got a plus cosine times cosine. That's cosine squared of x. Remember, we can use that notation to avoid having to write the parentheses. Then here, the 0 is not contributing, and we just got a negative times a negative, which is a positive, and sine times sine, which is sine squared. So down here, we got a sine squared of x. All over the original denominator, 1 plus cosine of x squared. Okay, a little bit more simplification that you can do. Don't forget that we've got the Pythagorean identity. Sine squared plus cosine squared equals 1. So for this part right here, if I want to simplify, I can actually write the number 1 there instead of that complicated part. So this is cosine of x plus 1. Well, that's the same thing as 1 plus cosine of x. So I'm going to choose to write it that way. So this is 1, oop, darn. So this is 1 plus cosine of x all over 1 plus cosine of x squared. Well, that's a 1 plus cosine of x times 1 plus cosine of x. So what's going to happen here is one of those can cancel. So the final simplified form here would be 1 over 1 plus cosine of x. Because a 1 plus cosine of x canceled with one of the 1 plus cosine x's in the denominator. So that's it. That's the derivative of sine x over 1 plus cosine of x. Thank you for your attention. Remember to go back and watch the video, pause it when necessary, and be sure to take notes on this.